Hi everyone, a little bit of disclaimer at the front. I am a bit tired today, so I might mess up one or two words, so just bear with me. But this is just a video to narrate this document for you. The other video is more about explaining the methodology of what you'll be needing to do for this investigation. This one is just narrating all the different parts and maybe adding in a mini explanation here and there. But for the most part, this is meant to model more closely something you might be doing as a test or similar to test conditions, which I believe the first end of topic test you guys did was a investigation. So I think, and you did pretty well with the last one with the running. So I believe you are all pretty well prepared for this, but this is just a bit of explanation to help you a bit more. And so, starting with the narration, this is for the air resistance investigation. And the aim for this is to investigate the effects of surface area on the time taken for a piece of paper to fall to the ground. And so, something really important to look at when we're going on to the discussion is to look at the aim and maybe look at some keywords I have in here, but I'll remind you when we get down there. And so, next part is just a overview of what we'll be doing. Over the next 3 days, we will complete an investigation in which you investigate the effect that mass and shape has on surface area. The three shapes we will be investigating are a flat piece of paper, a piece of paper folded into quarters, so folded into half twice, and a crumpled ball of paper. So what I mean by a piece of paper folded into quarters is here's a whole piece of paper, fold in half once, and fold in half twice, and experiment with it like this. Don't cut it or anything, just keep it exactly like this. And so, to recap, we are investigating a flat piece of paper folded into quarters, and a crumpled ball paper. And so your hypothesis is which shape do you think will take the longest to fall? That will be what your hypothesis is about. And then moving on to your variables. So what dependent variable? What is your dependent variable? And this is the one that you measure, just right in there. Independent variable, what is your independent variable? This is the one that you change. And controlled variables. What are your controlled variables? And you need to list at least 3 here. So moving on, method. Here you will need to write in stages what your method will be. You can write this in numbered steps. How many, and while you're doing that, how many trials will give you a fair test? So this is pretty self-explanatory, but you just need to write for this all the steps you take while you're doing your experiment. It's good to do a little draft before you start with your experiment, and then after you've done 1 or 2 trials, go through and work on it a bit more in depth, just so that way you have a plan for when you get started, but you can work on your method a bit more once you've done it a few times and you know what you're doing. And you also have to draw a diagram of the forces acting upon one of the shapes. And in your books or digital is fine, but insert a picture here. So with this, it's the same as the force diagrams we've been doing, but what you'll be doing for this is drawing the forces acting on either a whole piece of paper, a quarter of a piece of paper, or a ball of paper. And the forces will all be the same, but they may be differing strengths for this one. Moving on, results. You can do this here in your books, in Google Sheets or Excel, whichever is easier for you. This is, I just put a table here for you to look at, but you do need to have your results in a table. If it's not in a table, it won't be counted. You can make your table however you want, but it needs the independent variable and your dependent variable. Those are the most important things. And next, graph. For this, either draw it in your books, in Google Sheets or Excel, and insert a picture here. So what the graph needs is a correctly labeled axis, correct names on the axes, correct scale used, i.e. even and equal spacing between variables. This is more important if you're drawing it in your books. And straight lines if drawing it in your books. And an accurate trend line used. So for a trend line, I will do another little document to just tell you about what trend line is, just in case you don't know. But if you do know, you can avoid that document. Moving on, conclusion. So you do this after you've done all your experimenting and you've got your results and your graph. Comment on the relationship between the shape of the paper and the time taken for it to fall. Was your hypothesis correct? This is basically just saying this is what happened, this was the relationship I saw, and my hypothesis was correct or it was wrong. That's all you need to do. Next is discussion. In the discussion, you're explaining the science behind why your relationship happened. So I've given you a bit of hints here, but for this, it's basically why did one shape fall faster? And explain this using your force diagram and friction. And so for this, keywords I've suggested are friction, air resistance, surface area, mass, and gravity. There may be other words you want to use here, but these are the ones I do recommend using at the very least. And they all related to what we've been learning over the past week or so. And so finally your evaluation. How did you make your data reliable/valid? Comment on your controlled variables and your number of trials. That's most of the way of how you will be making your data reliable or valid. And what might you do better next time? So what's something you feel like didn't go quite so well that you feel like you could fix it by doing it in a slightly different way? And so that is everything. So for all this, you could either do it in your books or you can do it in this document I've given you. If you're doing it in your books, I do recommend following the layouts I have here, because, or at least looking at the doc, because over here it just has hints of what you need to put in each part. But I believe that is all you will need. Remember, you can always private comment or email if you are confused about anything in particular. But you'll be doing this over the next 3 days. So that means about 60 minutes total, which is kind of about the right amount of time for something like this. But that is all. If you're confused about the method, make sure to check out my other video that is also linked in this assignment. And good luck.